how do you develop how do you develop professional intuition short of just living it for 30 years?
Um, One thing you have to have is a willingness to try, right? To because the educational model is so calculation driven, you meet a lot of engineers who, particularly when it comes to existing buildings, like this building here,
Sure.
they'll say, this building doesn't work because because I can't quantify anything. Right, I'm looking at there used to be a nice big brick wall there,
Sure.
and they removed it, and they put these, I don't know, is that pink or purple or whatever color that is, to make a big open front.
Yeah.
Right. So how do you quantify the lateral load carrying system on this building? It's like, well, you don't, but here it is. So many people are just so afraid to try. Right? It's pounded into our heads. Two things. In college, it's pounded into our heads. You have to quantify. That's what engineers do. We quantify.
Sure.
Right. That's why people have Fitbits. You can't just go out for a walk with your wife. You got to say, I did 12,218 steps. I got to do 12,300 tomorrow. Right. Where it's pounded in our heads. You got to do calculations, and then as soon as you graduate, what's pounded in your head? Oh, you own this thing for the rest of your life. You have this unlimited liability. Like, even the most heartless attorneys are smart enough to realize that I don't have any money. There's no point in coming after me.
Sure.
My company, that's a different story. Company you work for, that's a different story. They have liability insurance. They have, these kind of things. But between quantifying it via calculation and then this fear of if there's a failure, I'm going to get sued. People could die. Well, yeah, that's true. When you look at the number of buildings that actually fall and collapse and people die, they're very few. As far as getting sued, it's not a question of if, it's a question of when. That's the way that we live nowadays. So, and buildings don't fall down because the footing was undersized by a factor of 4. They fall down because there was a detail that was missed somewhere. Maybe it was a roof leak that was undetected for 10 years. Maybe it was just something little, right? That it's not that the column here is undersized by a factor of 5. It's just the little details. You look at the big collapses over the years. It's always been a detail thing, something that you couldn't really quantify anyways. If you've got and I don't remember which bridge it was, I think it was Connecticut. There was a 3-span bridge, and the middle span was hung by hangers.
Okay.
So there was the end span that cantilevered out, the other end span cantilevered out, and the middle span was hung by hangers.
Was it those chain link?
No.
Okay.
It was a plate.
Yep.
with a bar.
Okay.
And I think it was done because it was calculatable.
Okay.
And what happened was the top, the main span beam had these 2 plates that came down. They straddled the beam web, and then there was a round bar connecting them.
Okay.
Well, it started rusting.
Yeah.
And it pushed those plates out so much that suddenly they weren't connected to that bar, and it fell down. It's like, you can't quantify that. You can't calculate that. It was a good detail. It worked until something that had nothing to do with calculations came along. So,
just sharing this detail, just not to derail our conversation. There was a mall in Canada Toronto, maybe one of the major cities, but I can't place it. And it was a mall with a parking deck structure, structural steel with a concrete and metal deck, and underneath it was like a food court space.
Mm-hmm.
And one of the bays collapsed. An engineer had assessed the thing a week prior and physically saw the connection ended up fail. It was a clip angle that just had ongoing leaks,
Yeah, yeah.
surface corrosion, but in the actual clip angle itself, it was rusting, jacking, and just broke. Hearing that story of that rusted detail has now spooked me forever into whatever I'm doing assessment about clip angles that are wet. But there's no equation that says, oh, there's been 10 gallons of water on this for 2 years.
Right, right, right. We should be conservative because people's lives are at risk. But we don't need to be so conservative that our buildings are unaffordable or unusable or anything like that.